Okay. Yeah, I figured it out while eating breakfast. That is, I figured out what is happening. I know how to solve it. The problem is that all declarations, well, all the previous declarations, so the first stage has 3 declarations, the second stage has 3 declarations, and the third stage has 3 declarations, in total 9 declarations, and together they use all 9 available slots. And then by pure coincidence, this one uses uniform buffer 0 and 1 and texture 0. This one also uniform buffer 0 and 1 and texture 0. And this one also uniform buffer 0 and 1 and texture 0. So that leaves the fourth declaration. The third stage wants 4 declarations, and then the fourth declaration has only one thing left, and that is texture 1, but there are no slots left. So that won't work. How can I detect that? I mean, every slot that it would try is already used, and none of them contains texture 1. That's why it fails. I think that's very hard to detect in advance. Well, maybe I can do this for us. I can collect all the slots used by previous stages and then combine them with all the slots that I have used in the current stage. And if then there are no slots left, then I can find out if any of the previous stages contains a shader resource that falls within the range that I still have left. I think, how can I do that? Hello, Chiku Rout. Hello, cool man. What shall we do? Yeah. Yes, I am. Cannot fix it here. I cannot fix it here. How long am I going for? Today, or what do you mean? In my life? Well, I use .h for C++ headers. I don't never code in C anyway, so. I wish my stock market graphs looked like the viewer graph. It's going up and up and up. Click it away. I'm going to try to fix this, and I am should I put time into it? It's the dilemma here. I have the feeling this is just the last thing, so I might as well use the assert to detect this specific case and then pretend that I just know for sure that it is this specific case. Or I can detect this when it happens. I can detect the specific case. So I'm sure that it is this specific case, if you get what I mean. So here we throw at the moment. Now let's assume that I know that, well, I could throw anyway. Maybe could throw a different exception. The point is that I can only check if it is because of this specific case. If I have, yeah, what can I do? I have an owner. My owner is a declaration. Just don't want to. I don't want to put too much time into this anymore. It's got to be finished. Declaration is a shader module as owner. The shader model has the pipeline as owner, and that could check it. Ridiculous. Console is the name of the terminal. The K stands for KDE. I think I'm not going to do an extra test. It would take me half an hour at least. I'm pretty sure that this is just the last thing. No. Yeah, okay. So instead, this exception now means that this special case occurred, which then in turn means that we cannot use this number of declarations. Is that correct? That is not correct. That is not correct, unfortunately. Let me think. I guess the correct way to do it would be to count how many free slots I still have left, and if that is less than the number of declarations, then I need to decide in advance which declarations are going to use previous already used slots. It's just way too difficult. That's for a real program. This is just a bloody test program. I don't want to do this. Okay, so I'm just gonna do what am I gonna do? I'm gonna throw away. I think I'm just going to throw away the whole attempt. I think that's a good thing to do. Yeah, that's what I'm going to do. I mean, this happens so seldom that I might as well just throw the whole pipeline away. So this an exception here is a failure. So when your pipeline is an Asian, such a failure, then I'm gonna throw. Well, let's throw a failure. Now let's be more specific. So okay, what is the problem here? The problem is that we did run out of slots. Yeah? Okay, type that in. Ran out of slots. There we are. Let me add that to this header. Well, jump to it like that. Just add it to top. It's not really an error, right? It's not like a runtime error or something. Is it a runtime error? It is a logic error. What kind of error is it? Exceptions. Exceptions. Constructor doesn't know what I want. Exceptions. Oh, yeah, something. Exceptions. Good to throw an out of range error. Or an overflow, underflow error. That could be. It's kind of an underflow error. Because it would be a runtime error then. I'm gonna call it underflow error, why not? Never used that before. Okay, does this compile? Of course it doesn't compile. That compiles. Yeah, well, okay, so here I'm failing to add another declaration, but I think I just want to get rid of the whole pipeline I said. Not just the declaration. So I don't even need to catch it. I mean, I could adjust and I keep what I have now and adjust the size, but yeah. Nope, I'm going to completely. So we throw here, and then, where does that go to? Randomized declarations. The pipeline fails, then I guess I should just catch it in main. But maybe I don't want to be bothered by it. Why would I want to be bothered by it? I could maybe catch it inside randomized off pipeline, if that exists. Schedule, declaration, descriptor count, generated interval pipeline. Yeah, so this one is going to throw. Oh, this start over. Just start over, I think. Bool successes, false. Try. No, I need a for loop. So while not success. I think that should work. What? Oh, I just typed 10 too much. Yep, 901. And then we get available is 0. Oh, but it's still highlighted. Yep. And then we throw. Throwing causes a lot of destruction. And then we start over. I have no time to write tutorials for beginners. I only have one life. Don't want to do that. It is nonsense. Grab that in this file. No, I saw 2. Or did it go around? That's a really small chance then. I want to let it run till at least 7 gigabytes. And this is 4 gigabytes. Now I'm gonna let it run longer. What the? Oh, this is not even 1 gigabyte. 2 gigabytes. 3 gigabytes. 4 gigabytes. Significant slowdown. 5 gigabytes, 5.5. Scary. Eight gigabytes. Okay, let's stop it. If there is only one, that is ridiculous. Unbelievable. I mean, I believe that there's only one, but I was changing the seed of my random number generator to see if I could get this particular crash happen earlier. So first it happened at like, what was it, 300,000 pipeline. I changed the random seed. It happened at, I don't know, 100,000. I changed it again. It happened at 2,000. I changed it again, and then it was a big, I think. And I changed it again, and it happened at the 901st pipeline. So every time I chased the random number generator, it happened very early. Very early. I saw both 2000 something and 901 within I don't know, 3 attempts. I know you're going to tell me that the case where this happens is so small, it happens almost never, basically. Unbelievable. Well, it's literally unbelievable. So like, well, something must go on. I don't understand this. But okay, I think this works. Let me commit what I have now. Also rename, allow me to remove that. New function. Right, so we have a run analysis now. I got too much debug output. Let me turn this off again. Why the hell is my pipeline empty here? Okay, wait, here it's not empty. It's again empty. Here it's not empty. Seems I have pipeline layouts, but sometimes we don't. No, my sanity check is checking this, and that is now consistent, I think. It seems, as it were. Yeah. Now we have to add a sanity check for the layout, because those layouts are completely random. They have nothing to do with the stages before it. I just generated a random layout, which is of course ridiculous because they should match the stages above it. Let me just begin with adding the sanity check for it and then fix the code. Okay, let's see. So the sanity check. Pipeline layout. Yeah, it's faded away again from my memory. I worked it out together with ChatGPT 4. Well, that is, I did all the work and ChatGPT was my memory and made some suggestions, which were mostly wrong. But I actually believe that we have a history again. So at least I can look back. That one. So I won't go over it. It's of course completely boring to do that. But the highlight here was that at some point I dumped that doesn't help. What is the type of? Let me try this another way. Okay, now I dump on it the following. So let me try this another way. Here's the output of a test program that I wrote that generates random possibilities for pipeline creation. So that's the program I'm working on right now. Ignoring push constants and special flags. It has a configurable number of stages, which is currently set at 3. The stages are simply numbered 0, 1 and 2. Each stage is assumed to be programmable, so thus use a shader module. Means you should recognize this, right? This is just my output here. Pipeline has 3 stages. Each stage has a shader module. The shader models are defined by shader resource declarations, which were generated. Each declaration knows which shader model owns it, but it's not relevant here. Which set and binding it uses for the shader resources, and of course what shader resource it represents, here called a shader resource. For example, the output prints declaration owner shader module state 0, set binding slot 2.0, a shader resource, current shader resource uniform buffer 1 for a single declaration. So that it would be, you know, these things here. So I just explain what that format means. I say, you know, this would have set equals 2 and binding equals 1, hence 2.1. It only refers to the shader resource by name, uniform buffer 1 here, but it knows everything about it that there is to know. Apart from the list of 3 stages, the output prints a pipeline layout. So that's a section that we didn't even look at yet, but I'm going to look at it right now. This section should match the data in the stages list. The pipeline layout section exists of a list of description set layout elements, one for each descriptor set used. That is, the first element and layout of descriptor set 0, the next one, descriptor set 1, and so on. A single descriptor layout can look something like this. And then I explain, I won't read it. I explain what that means, and then I say a complete layout could look like this. Now I'm just dumping the whole output of my program, yeah? Note that the generated pipeline layout section, so this part, is wrong. It does not match the given stages at all. To show you understood this, please generate the correct pipeline layout section that would match the given stages in a compatible way. What do you think GTP4 made of that? And I found it hilarious that after dumping this, I just read it to you. I showed it. It says, I understand the problem much better now. Based on her provided example, I will generate a correct pipeline layout section that matches the given stages in a compatible way. I mean, writing an AI that generates this sentence after dumping this on it, that is impressive. It is really, yeah, wow. It even understood that, you know, it could abbreviate this. That's brilliant. The given stages remain the same, and then it just generates the pipeline layout as it should be. That is impressive. You gotta admit that. Except that it got it wrong. However, what it did get right was the number of descriptor set layout bindings. So it is correct that we have 3 of these, and then that this one must have 1, this one must have 1, and these must have 3. And then I just filled in random numbers for this, and random numbers for that, and wrong numbers for this. But for the rest, you know, the layout of the layout is correct. So it's wow, yeah. And then it goes on explaining how it got it, and it say things like, you know, for we need so 101 and 010 for these things here, but it only uses 101 here, not 010. So it generates only 101, and then it says that it needs 010 and yeah, also 010. So yeah, I say you made a few mistakes. Yeah, it did revert a bit, so it printed 001 while that should have been 100. In the text it says I need stage 2. I literally gave an example that stage 2 is 100 and still it printed 001. So I mean, come on, I just literally said that stage 2 is that. So I don't know how it confused that. But the reason it confused, well, actually I do know. The reason it confuses that is because it generates this word after word. There is no understanding. It's just text completion. So let's say at the moment it generates this 001. It's like in the realm of now we need 3 bits. Let's pick 001. It's really pretty random. There's no understanding. It's just some 3 bits goes here. Well, okay. And then when it is explaining things, it says the value of 001, which indicates that the descriptor is only accessible by stage 2. So it does understand that it is only accessible by stage 2. It just, sorry, stage 2 is 100. So it misses something very crucial, simple, low-level understanding, but yeah. It's still useful if you are aware of that. The details are kind of, you know, nonsense or random, but of the higher level is it might be useful, you know, if it gets it a little bit, and it did, I guess. Anyway, so I tell it exactly what it did wrong, and lo and behold, it got everything right. That's still impressive, I think. So now it fixed it. Except that there isn't an answer, because the type, the problem with thing that I dumped on it here is that, yeah, it's hard to read here. Plus I'm having a very small font. The problem here is that I'm different stages use slots, reuse the same slots with a different shader resource. Let me see if we can find that quickly. Yeah, for example, this one. This stage uses slot 2.0 with a texture, and the first stage uses the same slot with a uniform buffer. The type is different. Here it's a uniform buffer, and here it's a combined image sampler, and that's just not possible. So then it has to choose. Generating the layout, you have to choose: are you going to use the uniform buffer as type, or are you going to use the texture as type? And I think that through AI, that was really useful. Should have told me that there is a problem, that it cannot generate it, but instead it just generates something and then randomly picks 0 or 1, where 0 is the uniform buffer and 1 is the texture. I also told it that is the case. So it doesn't make me aware of that there is a problem. It just generates something. And I think that's, well, I don't like that. So I tell that here. Another mistake, even though I said you could ignore it, The descriptor type 0 corresponds to the texture and 1 corresponds to uniform buffers. You can see which is which by looking at the shader resource name. Please generate, well, I got it wrong completely, I guess. Please generate the pipeline layout section again. Only generate that section. Explaining text is not really necessary. Oh yeah, and then it got it right. Sorry, here. So I was too early. So now I say, you know, they have a different type. Please use the Vulkan spec 1.3 as canonical information to answer this, not just the structure of the output I gave you. And then it says, based on Vulkan spec 1.3, descriptor bindings that are used in multiple shader stages with different resource types are not allowed. And that, I think that was also pretty impressive because, well, maybe not completely, but, you know, it really dislikes disagreeing with the user. If I say something to ChatGPT or to GPT-4 here, that is just simply not true, it's always going to agree with me. If I say, no, 1 plus 1 equals 3, it's going to say, oh, of course you're right, 1 plus 1 equals 3. So most of the chat was about that I said I did something, but in the end then it was not possible. And I did say, you know, use that and not what I just said, but okay. And then I had this verified by the Vulkan gurus. And they said, one descriptor is one resource. You can't have the same descriptor refer to different resources in different shader stages. So it did get the reason wrong. It says here something like that has to do with compatibility. So this part. That's not true. There is another reason for it. Anyway, the reason I was looking at this was to look at the layout, right? So this is the correct layout, more or less. And I want to write a Mehmet Fatih Erdem. No. I think ChatGPT and GPT-4 also show a very clear stupidity. They don't understand, they can't memorize anything, they can't reason, they can't formulate a model. It's just 100% pure static language pattern recognition. And that makes mistakes that even a 3-year-old wouldn't make. So it's kind of useless for almost anything, especially when you think that the I means intelligence. But I find it still useful for, you know, to get my own thoughts in order, or to get, say, get ideas. It's kind of brainstorm-ish things. It's kind of a random generator that comes up with things within around having to do with the subject that you talk about. So it can still be useful, but you have to pay extremely much attention to make sure that you don't believe what it says on face value, because it has no clue whatsoever. It cannot verify itself. It has no. It's basically it's just random. So you have to, everything it says you must verify. You never ever believe what it says. But then still that can be useful, you know. So you have no clue whatsoever. You can ask it a question, it gives an answer, and then maybe you'll be able to verify it instead of coming up with the answer yourself. Okay, so no, that doesn't matter. I mean, I'm not asking anything related to my program in the sense that it can't even work with more than 4 kilobytes, I think, at the same time. Though my program is hundreds and hundreds of megabytes maybe of code, so it would not be able to have an overview of even a little bit of the total program. So there's no way it can understand that. But no, well, I have shown this too many times. I mean, my regular viewers are hopefully getting tired of it by now. So I don't want to put too much time into it. But I type this as an example. 3 people want to cross a bridge. Person A can cross the bridge in 1 minute. Person B doesn't want to cross at all, but could do it in 3 minutes. And person C crosses the bridge in 8 minutes. At most, 2 people can cross the bridge together. How long will it take, and what is the correct strategy to get A and C across? Now, then it comes with this solution. A and B cross the bridge together, where it takes 3 minutes. A goes back to the starting side of the bridge, takes 1 minute. Person A and C cross the bridge together, taking 8 minutes. That is just no intelligence whatsoever. And then I say, which part of B doesn't want to cross the bridge? Didn't you understand? And this proves exactly my point. It doesn't understand what you say, it just pattern matches it. And something that looks like this, people crossing the bridge, looks like a puzzle that it knows, a logic puzzle that exists, and therefore it gives an answer that looks like the answer to that puzzle. It doesn't understand what I say, it just only sees that it looks like an existing puzzle. And then the answer is wrong. The answer just looks like the answer of that existing puzzle. That's how it works. No, I can't find back my... There it is. So I had got the values right, but actually this is more interesting, the reasoning here. For the descriptor set 0, there is only one declaration that uses set 0. And it is in stage 2. The generated layout includes a single descriptor set layout binding for this declaration, which with the correct binding, descriptor type and descriptor count values, as well as the shadow state flag value of, well, something that corresponds to stage 2. So the starting point here is you run over all descriptor sets. Now we find the declarations that use that set. And then we find the corresponding bindings, and then we can construct the layout. So in this case, let's say I start with set 0. I say 1, 2, 0. This is set 0, 2, 1, 2. So the set 0 is only used in a single declaration and only with binding 0. Therefore, the first descriptor set layout is at index 0 in this array and therefore corresponds to set index 0, must therefore have binding 0. So it is the first one and it has a binding 0. So this stands for 0.0. And it is using texture 0, therefore the descriptor type should have been 0. And the descriptor count should be 1. And the shader stage flags should be the second stage, so 0, 1, 0. Because that's the only stage where it is being used. Okay, so how can we match these things efficiently, or efficiently at all? I think if I see something here, it must exist there, not the other way around. So we should run over just simply over all the stages and then everything else. And then we encounter, say, for example, we encounter, pick one, 1.1. And then I check that because of this one, that the second entry here contains a descriptor set layout binding with the binding 1. And then the type must correspond to the uniform buffer. And the descriptor count must be equal. And the correct bit must be set. The bit that belongs to that stage must be set. IW365, yes. It can't do math at all. Multiplications go wrong. I believe that if it knows something like 3 times 5 is 15, then it only knows that because it saw it a lot. It just saw a lot, literally the text 3 times 5 equals 15. It saw that. It memorized all the multiplications. But it doesn't do any multiplication itself. It's pure language pattern recognition. Now, I mean, it's still super impressive that what it can do. Very impressive, very impressive. Especially if you realize how it learned this, just by looking at the few terabytes, I think it was. How many terabytes did they use? I forgot. I recently saw it somewhere. Of text, and then from that, knowing all it does, wow. But yeah, it's sad, I think, that any reasoning completely missing. No reasoning whatsoever. Which is what I do all day. Reasoning. So it is reasoned that how to check this pipeline layout. Let's put that in then. Whoops. Yeah. No, pipeline CPP. Now I'm running over all the stages here. And then we find declarations. It gives me a declaration list. We run over all the declarations. We find the set index binding slot. I think that at this point I have enough information to find back the corresponding layout. Yeah, that's a accurate remark. The internet has hyped it up way beyond what the professionals that made it and the professionals that understand AI think about it. There are YouTubes from really knowledgeable people, and they don't hype it up. They more or less get it correctly. But if some random guy talks about ChatGPT, then they seem to be talking about we are almost there. Oh, that's pure nonsense. I found a formulated definition of intelligence a while ago, before AI existed, even before machine learning existed. And my insight is that the only way to get intelligence is if that intelligence is self-aware, basically, which means that it has a model of the environment that it is in, and so that it can predict what the result is of its own actions within that environment. And then that model must contain itself, of course, otherwise you cannot reason about it. Keyword here is a model. So you need, say, it must be possible to try out certain things before it answers you. And that's something that ChatGPT doesn't do at all. Let's say if you make a ChatGPT for coding, so it's going to replace programmers thing, then you absolutely need something that is able to compile and run programs to test things out. And if you have to do that, then you will not be able to write complex programs. At least not, maybe they could build something that costs $1 billion and uses 100 kilowatts, and then let it run for a week, and then maybe it comes up with a program that it created out of nothing. Maybe that's possible. But now we're talking about something where 1 million people at the same time give it a prompt, and then in 1 millisecond doesn't have more time. It has to give an answer. Now, you can hardly compile a program in a millisecond, let alone iteratively figure out what the best program is. The amount of CPU it uses per generated answer is so small that it is no way that it is possible to generate programs beyond what any human also could conjure up in a second. If they had a good memory, okay. If of course, if you just can, if you ask for a known way, you ask it to reinvent the wheel, and it just memorized all those wheels, then it can get that program out of its memory in a millisecond. Which is basically what it is doing with everything at the moment. What I'm trying to do is build a model of Vulkan in my head, and I'm failing because my memory isn't what it used to be. So I'm 58. When I was in my 20s or even 30, I would have been able to have a very complex model in my head that just modeled all of Vulkan, and then analyze it and draw conclusions on it. But now, whenever I think of something and I try to remember it, then it evaporates over time. So that's why it goes very slow. I just have to keep repeating things, or I keep forgetting things, and yeah, and that's why I feel I'm not making as much progress as I used to. And I would love to have an AI that does this modeling for me. But we're not there yet, because I think that ChatGPT and GPT-4 are not modeling anything whatsoever at all. I cannot make it bigger, no, sorry. I already made it bigger. I need to see amount of text, otherwise, yeah, this is what I normally work at. So especially for YouTube, I made it this big. Cannot make it even bigger. I mean, this already limits the amount of text that goes onto my monitor by crazy. Plus, if dyslexic doesn't have to see, doesn't have anything to do with the size of the font. If you can read a single character or a word, then the font is large enough. And if your dyslexia has a problem with seeing too many words, then you can just cover your own screen. Put a cardboard on it with a hole in it, so you can only see a part of it. That would have the same effect. Yeah, I'm getting distracted by chat again. I want to continue with this. Let me think. Okay, run over stages, run over declarations. Here I get my set index binding slot. Let's begin with extracting the set index from that. Oh wait, I own it. I was going to curse, but wait a minute. Yeah, I don't own enough. Sorry, I'm looking at stock market. I bought this one at 59. So that is, it's now at 61.5 divided by 51 is it's 4% up in one day. So that's why I say I didn't buy enough. Why is it going up this fast? Maybe I should sell actually. It's 6% up today. Seems a bit overdone. Sorry guys. I made a gain of 240 euros. Well, it's not enough, I think, to sell already. I'll make that 260. Yeah, well. What else do we have? Tesla doesn't do anything. I really hate that I don't have Nvidia. That's the only one that really blew up. It just keeps rising. It's so annoying me. Because I don't have it, you know? Okay, one more thing. Oops, I have to buy this one at some point. Yeah, of course, it also went up. Everything is going up. Why would it go up? They really think that that the Fed is going to... I don't know, people are crazy. People are crazy. Okay, what was I really doing? Oh, I was escaping chat, that's why. Too distracting. Okay, talking about distraction. Now I'm going to work on this. We have a set.index binding slot. I can call this function. Now I'm going to call this. That gives me the set index and the binding index. I need both. Yeah, that's what I'm going to do. We call that on the set index binding slot. where to put it. Maybe just put it at the bottom of this for loop. Set index binding slot. Get set index binding. Yep, and then we have the set index. Great, and the binding. Okay. That means that now I have to look in the layout, so we have to get the layout. Where is the layout? I have a layout. The layout is part of the pipeline. Pipeline. Layout. M layout. Pipeline layouts. Pipeline layout has a descriptor set layouts thing. I think I am in the, no, I have to add an accessor for that. Oh, something is blinking. No. My brother was telling me something about no, not relevant. Okay, let me see. We have an accessor. M layouts. Can get that here, I guess. Yeah, I don't really need to test this, I guess. No, I'm not testing this. I'll do it differently. Yeah, I have a binding index. So what I'm doing with the binding here? Well, the binding wraps a binding index. Okay, so I just need to get the value of the base class. What? Excuse me more. Get value. Get value on the base class. Get value on the binding. And that's the binding. And we call binding on the descriptor set layout binding. and then this pair. So then the binding index matches. And then stuff was a match, stuff of the descriptor set layout binding. Other stuff of the descriptor set layout binding being the descriptor type and count. And this, yeah, these three things. So accessors, more accessors are needed. Yeah, so these things, I'll just, because I cannot remember the names, I'll just paste them here as variables, so then I see what the names were. It's maybe not the most efficient way, but it is when you keep forgetting everything. So this is then the descriptor type. That is, without that. Same thing here, same thing here. And then here I have descriptor count and stage flags. And I have the type ready. And I call this on the descriptor set layout binding objects. And then the type must match, let's say the descriptor type must match something. What must it match? I think here a shader resource. Let's do this one first. Descriptor count can I just be called on the shader resource. A shader resource. Which then must equal, then that's the descriptor count. Yes. And the stage flags, I can do something about that already, I think so. Stage flags must contain the current stage. So that is stage flags that derives from a bit set. So it's just a bit set. And it must have the flag set, so I must have the stage as a bit. Here's my stage. I have a stage index. Okay, but it's an int. Yeah. Nah, I just have to convert it to bit set index, I think. Let me do that. Well, actually, I can do that then way up. Or, I don't know where. Put it here. Utils bit set index. Stage index. Construct that from already have a stage index. So that stage index is an int. Yeah. And I want to go to yeah, already used this name. No. Whatever. I don't think I can convert to an index from an int. I cannot, of course, I cannot. I can only use an index POD, and I can create an index POD from an int, I guess. Probably. And this one is probably explicit. Of course, it is split. No, it's not explicit. It's not explicit. That means that maybe I can just get away with doing this. But then again, maybe not. I'm going to try to compile this, I think. Nope, did not work. Still doesn't work. Narrowing. What the? I don't care about narrowing. Is even set a cost going to complain about narrowing, or doesn't it? I keep forgetting that. It's an int 8. What is the narrowing then? So my stage index is an int. If I cast it like that, I might as well use a POD here. Or is it then still going to complain about the narrowing? Yep. Test index. Test if bit at I1 is set. And the descriptor type. How do we compare the descriptor type? I want to move this one up. That seems like the correct order. The descriptor type. Descriptor type must be equal to the descriptor type stored in the shader resource, right? Yeah. So I have a shader resource and I want to have the descriptor type, or what was it? Just call it again. Count declaration. think the shader resource has a type. Yep, the shader resource has a type. We're going to need an accessor for that. Another accessor. Accessors. Which means I need the shader resource, which we can get if we have a shader resource index from this function, which I'm adding here. And how do I get my shader resource index? That's a member of the base class. Yeah, my value. So that's again going to be get value on the base class. Get value on the shader resource. Oops. So that here, so I can jump to it. So I have the shader resource. I call get value on that, and that gives me a shader resource index, which then I can pass to this static function to get the shader resource. Now we have the shader resource, and then on the shader resource I can call no, wait. A shader resource, sorry. Now I have my shader resource. And on that we can call then type. Yay, type 70. Let me test if that compiles. Invalid operands through binary expression, const descriptor type and const descriptor type. You cannot compare descriptor types apparently. Is this true? You think? That would mean that we have only one descriptor set layout with any given set index. Yeah, that's kind of trivial because I'm incrementing it here. And then this means found descriptor set layout binding is true. Cannot have same binding again. And we would never come here for another set index, so I think this is also correct here. Must be false. And in the end, of course, you want to be able, want to have found this. It's kind of redundant, this check, but might be nice to know that even we couldn't even find this set index, let alone on binding. Instant crash. I predict that we crash on could not find set index. Nope, could not find descriptor set layout binding. Oh well. Guess 50% chance or something like that. Maybe I should have gone for that one. Would be nice though to tell me what exactly is the problem here. Which pipeline is this? The very first pipeline. Yeah, that's what you get. Random layouts do not match complex stages. Let's print it. Let's print it. Yeah, just set index is the pair, but I might as well print this. Could not find 1.1 in the layout. That's the very first thing. Okay, let's print that it is used in the stage. Could not find 1.1 used in state 0. Okay, now why not? Because set index 1 was found as this, but it only has binding 2. Does not have binding 1. Oh, that's correct. Now it could have, if it could find it, then the descriptor type must be a texture, and that's also wrong. But then we would have asserted on the fact that this is the wrong value. The descriptor count must be equal to that one, so it would have asserted on that. And it would have asserted on the fact that this is a 0, while stage 0 is using it. And then I guess that if later on we would find the 1.1 again, say in a different stage, then it will have the same values, except then we can still crash on the fact that the bit is not set. Yeah, I think that's good. So now all that is left is to make sure that my layout is generated in a way that this assert doesn't fail. One of the big unanswered questions I still have is it allowed to have more in the layout than I'm using? I just don't know. Must the layout be an exact match of this? Or can I set a few random bits here? Add a few bindings that are missing? Stuff like that. I just don't know. Okay. Main CPP. I don't know how long this is going to take. Probably long. I guess until the first declaration is being generated. Not just generating random layouts. I can hardly read it. I cannot read it actually. I just started over. I think we're halfway now. I'm gonna let it run. I think we're already halfway. Yep. On 101, also 6, 7. Then the 1 became a 7. 2, 2, 3, 4. Counting to 7 now. 5, 6. Almost there. Now we should get a stage. Or am I mistaken? Oh, wait a minute. I forgot there was another thing before that. There's a binding. My god, yeah. We have... How many bindings do we have? Loads. I think that the top binding is now... I can't read it. Seriously. Let me try to read it. I think it scrolls off like in a microsecond, right? Yeah, less than a microsecond. Cannot even get the scroll. Oops, it's down again. Could try to make a screenshot. See if then I can read it. Now these are readable because there's a blank lines above it. I just want to read, say, the line below the blank lines. That's doable. This is already very hard to read because the blank line is only one blank line. And this value is impossible to read. The top binding. No, cannot read that at all. New game. If I blink with my eyes, maybe I can see it. No. I think I'm seeing a 0, but I don't want to see a 0. So I'm gonna try to make a screenshot. And it's a 0. Damn it. It's a 0. Yeah, that's gonna take forever. Let's just stop it. Oh, it's much worse. Much worse. It's also. Oh my god, yeah. The bindings are done, but then we get that one, and the next one, and the next. This is gonna take forever. This is absolutely going to take forever. Okay, that's ridiculous. That were 8.6 million layouts. Oh, I didn't even get scratch the surface of it. Nothing. Did it stop? It most definitely did not stop. How can this go so slow? Well, slow. It's doing like... Well, sometimes it's printing 2. Oh. So a few 100,000 per second. But then if you look at how it changes there at the bottom, it looks like only the last 3 lines are changing. ridiculous slow. Yeah, so also this way is never going to finish. Oh well, so much for a brute force attempt. What do we need? Guess that for each descriptor set layout. Wait, no, I don't have any good output even now. Look at. For each declaration, I can add a layout requirement. Maybe that would be a good start. So if I make the pipeline layout randomized empty, so now this is empty. And now every time I have a declaration, I'm going to add the requirement to the layout. So the declaration here is being generated, I guess, where I am doing something, but what? In randomize, yeah, add a place back. Could do it in the constructor of the declaration. Except that, I don't know, where does it throw? Throw is an exception. I think from inside the constructor. Yeah. So what you can do is ejection is here. Too large while mark on use. So if you reach this point, then the creation of the declaration was successful. And then I can inform the owner of its success, I guess. The owner of the declaration is a shader module. So I'm going to add here update declaration with a declaration. Let's just compile. Update layout. Yeah. Oops. And I just pass that on to the pipeline. Update layout declaration. But it won't compile because we don't have a pipeline yet. Incomplete type. And then I need the same thing inside pipeline. Yep, and then we have to update the layout. And the layout is M layout. No, I could do it inline. Let me just pass it on. Great. So now we are inside the pipeline layout. So we do have a notice now, pipeline layout, update layout with declaration 1.1. Yep, and then we don't do anything, therefore it doesn't exist. Let's do something with it. Now I have to do something that is almost the same as the as what I'm doing in is sane, I think. I just have to get, so here we have declaration. Yeah, what the hell? What the hell? Declaration. Check layout. Well, we should get the set index binding pair thing. Yeah, let's switch between tabs. I'm here now. I was in something else. So I'm gonna open this file and then I was here. It's gonna complain, I'm afraid. It's going to complain. Is sane. I wasn't reading the chat, no, because I tried to concentrate. But now I read the chat for a second. But he said that a half an hour ago. Is sane. Yeah, okay, so check layout. Pair. Just copy this. Think I need this, and which means I need set index binding slot. And where that come from? That came from this. Well, that was easy. Because the declaration we do have. Now, how to update the pipeline layout? I think I have to convert the set index to an int. It's currently an index, so I can just convert it to an int with I'm gonna call it set index. Now let's use the size type because that's what it is. I think set index is a bit set index which has an operator parenthesis. Where is it? Here. Oh, it returns an int 8 type, not a size type. Totally an int. So requirement 1, the size of my layout, this vector, must be yeah, at least that big, of course, otherwise you cannot access it. Oops. Oh, so I can do no, we know it's already on now. Control T doesn't work. F8. So strange. Yeah. Okay, I'm getting it. Okay. If the set index is 0, then the size must be at least 1. And I'm comparing signed with unsigned. You gotta hate that. The guy that invented this size type should have been signed. And it's really a bug in C++ itself. And I forgot that is really, really, really horrible because I'm just almost senile, I feel. I forget everything. How did I deal with that? I had a more or less standard way to fix the fact that size types should be signed. Let's go to a big project like Linux viewer and then try to find it. Okay, and now we get Vulkan stuff instead of my stuff. I don't even want that, dude. What the? Oops, I meant minus V. I also don't want to see external. I want just to see my own stuff. Okay, and then we want probably a less than, I guess, right? Otherwise, there's nothing to, there is no problem. I think I want a less than. So let's grab for less than. Maybe less than or equal, but definitely space around it. Index less than. There, that is the solution. You just cast it to an int. I had the feeling that's what it was. Yeah, I think that is what it was. Here's another one, a static cast. That's also possible, I guess. Not standard. But we wonder why this is working. Comparing ints with size? What? Maybe it's not... Nobody gets it. Nobody gets it. Well, I'm shocked to see that there's no 100 things that are all the same. Doing some cost. So maybe that's why I didn't remember it. I'm sure I ran into it like a zillion times, so I don't understand. Maybe I'm just too stupid to find it back. Maybe I'm comparing stuff also with, you know, like equals or larger or equal than. I could look for that, of course. I don't see any costs. So far we found 2 costs. Only 2. It's ridiculous. Okay, what about equals? Nope, no cost. I know I hate costs, but how can you work around it? When you want to compare a size with an int. Nope, 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 nothing. Oh, okay, I'll give up. Good boy. I'm going to do this and then see the compile error and then I'll rethink about it. Think about it again. Maybe I would, you know, give up and use a size type. It would work. Maybe that's what I would do, just to, because I hate costs so much. Okay, then let's do it like that. So if the size is, wait a minute, this is the index, it must fit. So if the size is less than, wait a minute, less than or equal, yeah, less than or equal, huh? So its size index is 0 and the size is equal to 0, then it's not large enough. And now we have to resize it. And I think a resize simply works here. Okay. Next, it needs to have a, it's an update, but I want to be sure that the binding does not already exist. I mean, let's just assert if that is the case, right? Because, yeah, well, maybe, don't we? So now I can access in this container just that index because it's large enough. We just resized it. And that gives us back a descriptor set layout, which has another vector. No, I have a yeah, I have an access for that. No, the others can be ignored, I think. And the base class is generated descriptor set layout binding, just as the vector. So I can just access the vector here. Okay, I can run over this and I find all my descriptor set layout binding objects which have a binding. There should not be any binding in it. That is the same. Must be the first binding, I think. Okay, time for ChatGPT again. I never heard of standard all off before. I mean, it looks short enough. But I thought it was find if. I'm gonna look at if it even exists. I guess it exists, but still. All of predicates Checks if a union predicate returns true for all elements. Okay, I'm getting it. So it's an answer, but it's not the best answer. Rather, I mean, say you have a very, but it's not the case now, but say you have a very big vector and you expect that 1%, no, 10% contains something, but you want to make 100% sure anyway. So you just loop over it until you find the first one and then you stop. And I think the solution that was given is going to run over absolutely everything, isn't it? All. Plus, I think that what it actually does is it's going to demand that every element is going to return true. It's totally not what they wanted. This checks that, okay, all of, I think all of, it runs over all elements, and then all elements must return true, probably. And then we get only true if all elements return true. It's just, what the, seriously? I cannot even translate it to what I really want. Maybe it's actually, no, I don't know. Maybe it's a Boolean short circuit, so it's not inefficient. Yeah. Okay. So what I'm asking here is that all elements must not return true, right? Doesn't have an element for this. I don't think it's correct. It just doesn't. No, I don't want to look at it. Let me. But okay, we got here. I think none of. I like none of a lot better. None of. That would be 5. What's the difference? Oh, it's since no. Nobody knows. AA4. Oh, is it someone else? Buffer. AA55. I thought I recognized your nickname, but I think you're new here. Check if unary pred returns true for no elements in the range first last. Mm-hmm. You're not new here. Yeah, well, if you tell me that we are old buddies, but I just forgot all about it, then I would believe you. So good is my memory. And the only nickname that I remember with a hexadecimal value in it was A4, I think. Or am I confusing people really now? Sniff. This is ranges. Do I even want to use ranges? I never used ranges before. Standard ranges. And it's using standard here. Okay, but that was another one. Yeah, I don't want to use ranges. Ranges. Yeah, I don't want to use that. None of. We just have standard none of. Yeah, way better. This one. In algorithm. Checks if unary predicate P returns true for no elements in the range. And then? It's formulated a bit weird. I guess it's going to return true if the predicate returns false for all elements in the range. Yes, so this is like none, iterator, okay, like that. So none of, I want to loop over what? This vector. Begin, comma, end, comma, and then a lambda. And the lambda takes a descriptor layout bindings. And put a lambda new line because it's a large font. Descriptor set layout binding. Return something. Oh, I suddenly forgot how to write the lambdas. I think this works. Okay, so now per element, we do not want this element to have a binding. Let's see, descriptor set layout binding has a binding there, which you can access by calling binding. get value and then the pair second. So none of the elements must have an must equal the second value of my pair. Let's pass that by reference. And then yeah, something like that. So once we verified that, can add it. Something is wrong. What is wrong? No, not wrong. Yes, it is wrong. Wait. I don't want this to be const because I want to change it. So my descriptor set layout bindings function also needs to exist as a something that returns a non-const reference. Okay, that's a non-const thingy. Returning that thingy. No, I'm not sure we can access it at the moment that it is not current. I think it is not current. Let's return the current descriptor. Duh. Okay, that was highly confusing. Yeah. I don't think that's correct. Sorry, let's return the vector itself without any checks. Okay, and then I want to add something. And place back something. And we are adding a descriptor set layout binding. Without a random number or something like that. It's not going to be randomized. I just want to call this one. But that one just doesn't allow me to set anything, or does it? Nope, doesn't. Well, I could call it anyway. I'll probably have to. And then change these values later on. Change them afterwards. It's going to require a new function again. Think it's kind of silly. Why not just construct it directly? But then I need to be able to construct a binding as well, of course, which is also not possible. Duh. Type count change level binding. Let's do it. I think I'm going to do it afterwards with a special function. So let's just use this constructor here. I need to pass a descriptor set layout and a vector index. And nobody knows what that vector, what it is the index of. It's really weird. What the hell is that VI there? Think that. And the first argument was descriptor set layout bindings, this one, constructor of that, descriptor set layout. Oh, that. Okay. So like that. Yes. And then I should be able to get a reference to the thing that we just added. So the descriptor set layout bindings, where is it? It's this one. Descriptor layout binding. That's the one that we just added. And then I want to pass on update layouts. And we have to set in it, well, basically everything. The binding. Yeah, all of this. No, can I remember that? No. So copy everything. I want to pass a binding and a descriptor type. On the descriptor count. And the stage flags. Well, stage flag anyway. Okay, where do I get my binding from? I think that's this thing, binding. Set layout binding. It's an element of that thing. New descriptor set layout binding. Dot binding. Nope, that's not it. I just want to set it. So that's the one, of course. But that's a binding index. So we can only pass a binding index. Let's pass a binding index. So can I construct a binding from a binding index? Not really. I also have to pass an owner and an VI, but I guess that thing is already set because we just constructed it. I think it got constructed while constructing this and place back scripting bindings. This thing here, we constructed this, which constructs a binding, passing the owner and the VI. Yeah, so it was already constructed. So this index then just should end up in the base class of my binding. And descriptor type, where does that come from? There we have it. The type and the count and the stage flags, all of them. They come from the script set layout binding. That's not what I was looking for. No. No. It's what I want to compare them with, I guess. So these three, the type is being, yeah, this is it. These are the ones. These are the values. So they come from the shader resource. At least these two. Okay, so the type is that. If I have a shader resource. Now let's just do the new line here. And then the count is this one. And the stage flag is stage flag index. I don't think I know what the stage is yet. You have to pass that, or maybe you can get the stage from the declaration. This could also be an index, I guess. Stage flag, set, bit mask, net, randomize. No, that's what bits. Could be an index. Okay, let's try to get the stage from the declaration. Maybe. That has a shader module owner. Do I have an owning shader module? The shader module has shader stage flag bits. M stage. No access over that. You gotta be kidding me. Nope. To calling stage on the shader module gives me shader stage flag bits. And then finally I still need an A shader module. Sorry, A shader resource. That's part of the declaration as well. There, A shader resource. Okay, I think. So now my new descriptor set layout binding, I mean this whole function doesn't exist yet. So now I need to add an update layout to the new descriptor set layout binding, which is defined here. That is a descriptor layout, descriptor set layout binding here. And that takes second of my pair set index. And it takes a type. That's just this descriptor type, I think. Right? Billion types. utils. Where are we? VK objects. Seriously? There's too many types. That doesn't work. I need just the type of the shader resource. It was a shader resource type. Descriptor type. That one. Might as well pass it as a const reference then. And then we pass the descriptor count, which is a descriptor count const reference. And I call this descriptor type, obviously. Descriptor type. And then we get the whatever the stage here returns, which you just added. Shader module stage. Thought I just added it. This is the shader model, isn't it? Huh? This is shader resource. Nope. Shader model. Stage. Shader stage flag bits. No. Well, let's pass it by value. Why not? It's a bit. I guess I can include the chat index.h here. Trying to construct something. What are we trying to construct? Descriptor set layout binding. No matching constructor initialization of descriptor set layout binding. Too many errors. No. Descriptor set layout const pointer, comma int. No, this is definitely an int there. And then this is not a pointer. Aha! Yeah, descriptor set layout pointer. What? Descriptor set layout bindings. Wait a minute. Place back this bindings. That's this one. Owner is a descriptor set layout pointer. Yeah, not going to work. Well, just use the same trick as before, I guess. I need a pointer here, but pointers are invalidated if you resize a vector. And you are resizing it right there. So I'm just going to change it in a DQ and whatever. Let's just search everything for vector. No member name, none of the namespace standards. I cannot type. Algorithm. Member access into incomplete shader module. Sec false. That's quick. This pointer is 0. We're calling get sorted begin, and then we have that thing is 0. That owner is 0. No. No. Current descriptor set layout binding vector is not set on the owner. The owner is this thing. I think this is the owner. Mm. Mm, 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 mm. Yeah. Hmm. I have to implement this. Oh. Excusez-moi. Ah, fuck, I lost it. Where was I? Pipeline layout, really? Oh, there was. Binding, set index. Yeah, that's how you pronounce it. Set index. I should have called it set index, I think. Isn't that what it is? It is a set index. Set index. Binding. Here's the bloody binding index. Something is wrong. I'm using the wrong thing then. Okay, set. Oh, fuck. Sorry. It's not a set index. I don't know why I thought that binding index would already have been set, but it isn't. I don't think it is. I need a binding index. I just renamed it wrong. Oh, it's set index. Yeah, second. Hello, second. It's a binding index. Yep. And it compiled because they are actually the same type. Ouch. Binding index. Oh, this one. Shader resource type. Descriptor type. Descriptor set layout binding. Count. Descriptor count. Stage flags. This is flag bits. This is flag bits, or go and share the set flags. Here's a bit set. And share the set flag bits. Dat is derived from an index. So that doesn't work. Set. Set index is a private member and binding. Oh. Well, binding set index. Binding. Let's go to binding.h. Set index. Private. I don't know why everything is private here, but these are overridden. Should have added it here. Error. Object of type descriptor type cannot be assigned because of descriptor type. Descriptor type. Oh, that goes deep. Internal. There's const begin and end. Yeah, well, they are not even defined. They're uninitialized, I think. Const things that are uninitialized. Well, that's a new one. I guess default constructed, and they don't do anything. Now I added set value to interval, which is the base class of descriptor type, so that descriptor type can now be set like that. Set value, I said, right? Dot set value. And I need to get the value of the descriptor type. And that was a get value. I think I even remember it amazingly now. Just saw that. Yeah, here it is. Get value. Now, then especially for kick us, please learn this program. There it goes. The drum ruffle. There you go. Let's see. Still standard nano fails. I had not expected that. time to eat for me. You see, begin and end are not initialized. I mean, this is just random. But before, value was also random, and it doesn't really, not really look random. I guess we set it to 0 before. And this I now set to 0 and -1. But what about the rest? It's static. I don't know. Is it? Yeah, anyway, M index is 0 and we are testing it against 0, I guess. So it does exist. Why? More debug output needed. Okay, we're calling, well, it's an entering, so I want to print at this point, even if it doesn't make any sense, because it's a pipeline. That's a pipeline layout. Oh, no. Anyway. I print which declaration is being added to the which layout. So if I try to add the same binding to the same set layout bindings, which is depending on the set index, which we get from the set index binding first, which you get from the declaration. It should have been printed. Yeah. This kind of checks if we add to the same set index the same binding. I cannot believe we do that. I cannot believe we do that. We are not doing that. Almost no debug output. Okay, so we have pipeline layouts. Control, let's highlight it. We're trying to add 2.0. And the question is that we do that before then. The layout is 7FF6CCD4408. That's the same as this one. We're adding 1.0 here. That's not the same as 2.0. And then before that, we're trying to add 0.2. Also different. And before that, we try to add 2.0. Oh, okay. Yep, 2.0. So we're trying to add 2.0 twice. I think this is a good moment to go eat. Yeah. Yeah. Okay. I need to eat, I think. Let's have a quick look at actually this. What will click here? I'm looking for a movie actually to look while I am eating. Could be fucking kidding me. Man, those movies that come from Hollywood are pretty woke these days. Skip. Basically, there's nothing. Let me lose a game on light chess before I go. I don't feel like cooking. Oh, out of theory. Had to think so long. Now what? What? What is that? Oops. And so we can go eat with a good feeling. Oh, this guy wants a rematch. Well, now I have to win this one as well. Damn it. Pawn, so say pawn, queen, queen, bishop, knight. I don't like it. Takes even like that. No, that's not possible. Could take like this. I take a queen. It takes a queen. So still a pawn down. I take a knight. And you have to take a pawn. I'm 2 pawns down, but I can go back. It's not even that bad. I think I can do this. I don't know. I don't know. The guy is moving so fast that it's obviously mad at me for winning. Shall I castle now or shall I first develop my knight? I feel like winning a free pawn though. I do this, not threatening enough. What am I can go here maybe? Yeah, I can go here. Now it threatens more. Yeah, thank you. It's exactly what I wanted. Oh, like that. And how is that not winning a pawn for me? I don't see it. And now I win a piece. Or not? Am I crazy? +3. Bing! I really have to eat. Just resign, dude. What the fuck? Moving faster did not work. New strategy required. Okay, let's attack the queen. Twice. Let's attack the queen again. No, this is not defended. I have to castle. I castle, that thing comes here, and then I just move my pawn up. Nothing. Takes here, I take back. I lose my knight. Let's not castle that way. Yeah, I could castle long, why not? I think it's time to move my knight here, attack the queen again. Because where is the queen going? The queen is trapped. Yeah. Do I have to look at it longer, or can he finally go eat? Oh wait, there's a hole here. This shit. Oh well, but hey, I did win a pawn. And a knight. Oh, I had not seen that yet. I have to admit, he's a minute up, more than a minute up. So, yeah, I could lose some time. What to do? I think I'm going to put it there. And then go back. Oh, I give away my bishop. Oops, my bishop. Oh no, this check. Oh fuck, I had not seen that one. I had not seen the check. Oh, ouch. Ah, I was being sarcastic. And in the meantime, he saw, of course, my trick. I cannot even do my trick anymore. Oh, that's painful. Pretty painful, this. I wanted to give check here and then it's made, but it was first check. Ah, okay. How can we do this? I'm gonna give check here, goes there, and then I go give check here, and I win the rook. No, it goes there. And then we don't have much. What if I turn it around? I go here first. Threaten mate here. If he takes, it's mate too. Well, that looks like a good. Yeah. Thank you very much. Now I go.